Good afternoon, everyone. Thank you for coming to this CAST seminar, which will be which we'll be hearing today from David Clark from the University of Melbourne. Before I begin, I would just like to start by sharing my respects and acknowledging the Daruk and the Aurora elders past and present on which I am currently hosting this seminar. I'm excited to be hosting this seminar today with David Clark, who is today, well, let's talk a bit more about David's background. David has graduated with a Master of Science in Epidemiology at the University of Melbourne and has been working with the Allergy and Lung Health Unit. David has a keen interest in respiratory outcomes and is looking forward to commencing his PhD journey. And today he'll be talking to us about the association between traffic-related air pollution and obstructive sleep apnea. So I'm very excited to be hearing about this. And David, I'll pass over to you.
Hey, thank you for the lovely introduction, Nathan. I would like to say thank you to Nathan for extending the invitation and provided me with this opportunity to talk about my research findings with the group. Okay, so I'm going to start off by sharing a little bit about myself, about my journey from biomedical science to epidemiology. I completed an honors year in 2017 at the Florey Institute of Neuroscience, where I examined a traumatic brain injury model in rats. I have an image here of some of the rats that I looked after, and yes, they do bite. They were generally quite friendly, but do get a bit grumpy when you bring out a big syringe and inject them with nasty things. I also had the opportunity to learn about the most fascinating technique in molecular science, which is fluorescent immunohistochemistry. So this technique allows you to tag molecular markers with a fluorescent dye and generates very pretty images, as you can see. And of course, I was more than thrilled to publish my very first author paper from the work that I did. So after my honors year, I developed an interest in looking at the natural history of diseases and the idea behind how one lives one's life can influence their health outcome fascinated me more than doing lab work. So then I approached Shamli for a project in respiratory health. And when I first met Shamli, I thought to myself, my goodness, I've never met anyone with so many qualifications and credentials before in my life. And of course, over the years, she kept getting more and more credentials. But without a doubt, she was a fantastic lecturer and supervisor as well. So my Masters of Epi, I completed 2 projects looking at the association between air pollution and sleep apnea. And the reason why I chose air pollution is because I think that air pollution has such a tremendous impact on our health. And having the luxury of breathing clean air is something that we take for granted every single day. So today I'll be presenting these 2 projects that I did in 2019 with the focus on the second project, and I would really value your input in my analysis. Just a bit of background. I'm sure that almost everyone here has got a snoring story to tell, and often an unpleasant one. Just imagine being woken up from your slumber for the 5th time in a night, aggravated by the thunderous groans emitted by the sleeping chainsaw beside you. At times like this, a polite nudge with the hope of making the jackhammer-like sound disappear probably does not serve enough justice. So there is such a thing as occasional benign snoring without an underlying condition. Perhaps the unlucky end of the genetic straw has caused the person to have a narrower airway than most people. But persisting loud snoring or gasping for air during sleep should not be treated as a comical issue and may be related with a serious medical condition known as obstructive sleep apnea. So obstructive sleep apnea is the most common form of sleep disruptive breathing. In a 2019 paper published in the Lancet Respiratory Medicine, it is estimated that almost 1 billion adults between 30 to 69 years of age worldwide have some form of sleep apnea. The condition is characterized by 2 events. A person with sleep apnea can either momentarily cease to breathe during sleep, known as an apneic event, or their breathing is severely restricted, known as a hypopneic event. And this is typically caused by a partially blocked or a collapsed airway. As the person ages, the muscles controlling the upper airway tissues become more slack, and having excess body fat also puts more pressure on the airways. And other factors such as family history, male gender, and postmenopausal state in women can also contribute to sleep apnea. But regardless of the condition, of the cause, the condition is seldomly harmless. So we all know how essential it is for good health that we get an adequate amount of sleep each night. But people suffering from sleep apnea are not able to have a restful sleep. So when breathing is obstructed, the brain as well as other organs do not get enough oxygen. This is known as intermittent hypoxia. And this forces the body to wake up to gasp for air. And when this happens multiple times during a night, it leads to a fragmented sleep. And the danger of poor sleep goes beyond the immediate risk of having excess daytime sleepiness and impaired concentration, as the disorders has also been shown to link to other serious health complications such as heart problems, dementia, depression, and even early death. This order is more prevalent in adults and in males, and this drastically increases as people age. According to a study in Australia, sleep apnea remains largely underdiagnosed because people are not aware that they have the condition. So how is sleep apnea detected in the population? A person may present themselves to a GP if they have one or more of the telltale signs, such as loud snoring, restless sleep, cognitive deficits, and so on. The person would then be asked to complete one or more of these screening questionnaires. Although the sensitivity and the specificity of these questionnaires are quite poor. People at high risk are then referred to have a sleep test, which can be done at the clinic or can be done at home. The diagnostic measurement for sleep apnea is known as the apnea-hypopnea index, which measures the number of apnea and hypopnea events per hour. And the severity of sleep apnea is then calculated from the measured index. So the etiology of sleep apnea is multifactorial and involves both modifiable and non-modifiable risk factors. However, considerable variability in the prevalence of sleep apnea is unexplained by these factors and may be potentially related to other external environmental factors. In recent years, there is a growing interest in looking at the association between air pollution and sleep apnea, partly because the upper respiratory tract, including the nose and upper airway, is the first entry point of air contaminants. So this leads to the logical question of whether air pollution exposure is associated with sleep apnea, or actually causes sleep apnea. So when we think about air pollution, CTs covered in smog come to mind, but the lack of visible smog is no indication of healthy air, because just about every human on the planet is breathing in unhealthy air, according to recent reports from the World Health Organization in 2018. So as we have a group of air pollution experts here today, I won't delve into too much details about air pollution in this presentation. But I do want to stress the point that the impact of polluted air on our health is tremendous, because just about every lung illness and respiratory conditions can be attributed to air pollution worldwide. So as you all may be aware, the deteriorating air quality in both cities and urban areas are mainly caused by our reliance on motor vehicles and the burning of fossil fuels for energy from various industrial facilities. And air pollution can be derived from household factors as well, such as cleaning products, using open fires for basic stoves for cooking in some countries. Air pollution is a complex mixture of particulate matter, often indexed as PM, and other gaseous components. And in relation to respiratory system, coarse particles that we breathe in can deposit in the upper airways, while the smaller particles can penetrate deeper into the lungs, and the ultrafine particles can even get trapped in the alveoli of the lungs and can enter the systemic circulation as well. And you may be wondering, how is air pollution related to obstructive sleep apnea? And the quick question is that the mechanism is not well understood. But one of the proposed pathophysiological mechanisms leading to the development of sleep apnea is thought to be similar to allergy-mediated diseases, in that inspired air pollutants may get trapped in the nasal mucosa region, where they interact with various antigen-specific receptors that leads to an inflammatory response and airway edema, which then which then reduces the airway patency, leading to obstructive sleep apnea. So to date, limited studies have investigated the relationship between air pollution and sleep apnea. And studies in this area also generated conflicting results for different seasons of the year, which is quite plausible, given that fluctuations in temperature and humidity levels can influence the level of air pollution. Air pollution levels can also vary between developing and developed countries, but it is unclear if this will have a differential impact on the risk of sleep apnea. So there was a systematic review published in 2017, and this study suggested a positive correlation between high levels of air pollution and a greater risk for sleep disordered breathing, including sleep apnea. But this study only conducted studies in children. And there was no published data on available data based on systematically synthesized information on the relationship between air pollution and sleep apnea in adults. This is an important knowledge gap, given that the burden of sleep apnea is much higher in adults. And furthermore, seasonality, temperature and humidity as potential confounders or effect modifiers were not taken into consideration in this systematic review. So the main objective of my systematic review is to determine the association of air pollution and obstructive sleep apnea in both adults and children in the general population, and whether the variability in seasons, temperature and humidity can influence the impact of air pollution on sleep apnea. And just very briefly, this systematic review was prospectively registered in Prospero. I used 3 different databases to search for papers published in English in peer-reviewed journals up until September 25th, 2019. And my inclusion criteria were studies that objectively measured sleep apnea using a sleep test and must report one of the sleep apnea indices, such as the apnea-hypopnea index, the oxygen desaturation index, and the less commonly used respiratory disturbance index. The searches generated 441 articles, and after removing duplicates, screening for the titles and the abstracts, I further removed studies that examined obstructive sleep apnea purely based on screening questionnaires, and studies with poor quality as well. And at the end, only 5 articles were included in my systematic review. I used the Robbins E tool to assess the risk of bias in 7 different components for each of the studies. And these were the bias due to confounding, selection of participants, classification of exposure, departure from intended exposure, missing data, and so on. And each component was rated between low to critical. And studies rated with a critical risk of bias were removed from my review. And the two studies looked at, the two studies with a critical risk of bias looked at the association between air pollution and sleep apnea without adequately adjusting for confounding variables. So that's the reason why I removed from my review. So this is a busy slide, but I just want to highlight a few things. There were two studies conducted in the US, one study in Europe, and two studies in Asia. So this review did not pick up any study conducted in low-income countries. And looking at the different age groups, we can see that on average, participants are middle age. And I just want to highlight that the measured air pollution levels in these studies on average were above the recommended air quality guidelines by the World Health Organization. So this table here briefly summarizes the associations between traffic-related air pollution and sleep apnea for the studies that were included in my review. So I was not able to collate the measurements and present them in a nice graph due to the heterogeneity of the outcome definition and the different time windows over which pollutions were measured in these studies, with no two studies using the same measurements. So going across the table here are the different lengths of exposure to various air pollutants, and a plus indicates that there is an increase. A plus indicates an increase in air pollution exposure is associated with increased risk for sleep apnea. And as we can see, overall, there is a suggestion of an association between air pollution exposure and sleep apnea, although the evidence is inconsistent for the duration of exposure to the PMs 2.5, PMs 10, and the nitric oxide. And notably, there is an interaction of air pollution in different seasons of the year as well, depending on the country. So in summary, there is a lack of well-designed studies looking at sleep apnea in children and from low-income countries. The risk of sleep apnea is expected to be higher in low-income countries, such as there is a significant disparity in the exposure to air pollution between middle to high versus low-income countries, resulting from poverty and energy sources used in the low-income countries. There is some evidence to support the relationship between air pollution and sleep apnea, and that seasonal variation should be taken into consideration when performing analysis. The study showed that even a concentration of air pollution that is below the World Health Organization air quality guidelines, there can still be a positive correlation with the risk for sleep apnea. And this has important public health implications and warrants the continued vigilance in monitoring and mitigating of air pollution worldwide. The final thing, air pollution, air quality may be different compared to outdoor, and higher levels are possible indoors in otherwise low polluted countries, and especially when people live in poorly ventilated spaces. So now I'm going to present the findings from my second project using data from the Tasmanian Longitudinal Health Study. So the results from my systematic review show that an air pollution threshold that triggers obstructive sleep apnea has not been determined. Therefore, it is unclear whether the low levels of air pollution found in countries such as Australia are associated with sleep apnea. And furthermore, most studies were cross-sectional analysis, and only 2 studies have looked at this association over an extended period of years to decades. So the main objective of my original analysis is to determine the association between traffic-related air pollution and obstructive sleep apnea at middle age, and also to investigate the potential effect modifiers by smoking status and current asthma status as well. So there are various physiobiological and lifestyle factors that may affect the disparity in severity for sleep apnea and the body's innate response to oxidative stress in the context of prolonged exposure to air pollution. In particular, tobacco smoke can induce oxidative stress, leading to the thickening of the uvula and the mucosal lining, which has been implicated in the severity of sleep apnea in a number of studies. And I've just cited a study from Kim in 2012 here. The results from this study showed that smokers were more likely to have severe obstructive sleep apnea, and that the severity of sleep apnea is correlated with the duration of smoking. These are the photos showing the histological changes in the upper airway mucosa in obstructive sleep apnea patients. And we can observe that there is an increase in the thickness. There is an increase in the thickness and edema of the uvular mucosal lamina propria, which is this white layer here. And this is observed in moderate to severe obstructive sleep apnea patients. And only smokers had significant changes in the uvular mucosal histology. So in addition to upper airway irritation triggered by cigarette smoke, there may be considerable interaction between diseases of the lower airways, such as asthma, which can reinforce the hyperresponsiveness of the upper airway. And this idea stems from the United Airway theory, which posits that diseases of the upper and the lower airways share the same inflammatory process within the airway. Hence, it is possible that inflammation distally in the case of asthma can trigger the same process in the upper airway and can affect airway patency in obstructive sleep apnea. In a meta-analysis by Kong in 2017, we can see that obstructive sleep apnea is highly prevalent in asthmatic people. So for the current study, the study population is from the Tasmanian longitudinal health study. And briefly, the TAS cohort consists of approximately 8,600 children born in 1961. These children were recruited into the study in 1968, known as the baseline survey study. And there had been various other follow-up studies conducted since, with the most recent follow-up completed in 2016, when the participants were on average 53 years old. And the current, the performed analysis focused on participants at 45 years old and 53 years old. At 45 years old, approximately 5,000 participants had their residential address geocoded. And of these, 3,000 participants also participated in the 53-year follow-up study. And a 53-year follow-up study, approximately 3,400 participants were screened for sleep apnea using the stop bang instrument. And a subset of these participants had a home sleep test to more objectively define sleep apnea. So the stop bang instrument is a self-reported 8-item questionnaire. The first 4 questions used to assess troublesome snoring, tiredness during daytime, witness sleep apnea, and hypertension. And the latter 4 questions are related to the body mass index, age, neck circumference, and gender. The risk for having sleep apnea is given a score out of 8, and the higher the score, the more likely that the person would have sleep apnea. And in a primary care setting, the person would then be referred to have a sleep test to diagnose sleep apnea. So the stop bang questionnaire has previously been validated within the same sample population, and it was determined that the cutoff score of 5 out of 8 would maximize the sensitivity and particularly the specificity of the questionnaire. And so the optimal cutoff score of at least 5 out of 8 for the stop bang items questionnaire was used to define probable obstructive sleep apnea, which is the probability that the person has high risk of sleep apnea, the main outcome of this study. So the exposures of interest were traffic-related air pollution, exposure at 45 and 53 years of age. I looked at two main air pollutant components, PM2.5 and nitric oxide. The amount of air pollution exposure was assigned using a satellite-based land use regression modeling technique. And I also looked at distance from a major road of less than 200 meters or greater than 200 meters as an exposure. So I chose the distance of 200 meters because it has been noted that there is a sharp decay in the concentration level of air pollution downwind at 200 meters from a major road. So this basically means that at a distance that is greater than 200 meters from a highway or major road, air pollution concentration generally approaches the ambient city-wide air pollution concentration. As for the outcome for sleep apnea at 53 years of age, for the main analysis, I used the stop bang questionnaire to look at probable obstructive sleep apnea. And for the sensitivity analysis, I looked at obstructive sleep apnea more objectively using the apnea-hypopnea index, which was measured using the home sleep test. So I used a cross-sectional analysis to look at the association between trap exposure and sleep apnea at 53 years of age. I used a longitudinal analysis to look at the long-term exposure to trap to see whether trap exposure at 53 years of age is associated with sleep apnea at 53 years of age, and whether these associations were modified by smoking and asthma statuses. For my sensitivity analyses, I looked at the subset of participants who remain at the same residential address at 2 time points, and also a subset of those that further had a home sleep test. So this table summarizes the characteristics of the participants at 53 years of age, and I just want to highlight a few things from this table. Participants tended to have a high body mass index, and the majority were non-smokers or ex-smokers. 30% of the participants were asthmatics, 15% were identified as having probable sleep apnea, and of those that had a sleep test, almost half were identified as having mild to severe sleep apnea. So this table shows the distribution of air pollution and proximity to a major road at 2 time points. And as you can see, approximately 26% of the participants lived within 200 meters from a major road at both time points. And I just want to highlight that the annual mean concentrations for nitric oxide and PM2.5 were well below the recommended air quality guidelines by several folds. And participants who lived within 200 meters from a major road were exposed to a greater annual mean concentration of nitric oxide at both time points. And we didn't see this relationship with the PM2.5. For the cross-sectional and longitudinal analyses, there was no association between the annual mean NO2 or PM2.5 exposures at 45 and 53 years and probable sleep apnea at 53 years of age. And similarly, there was no association between living within 200 meters from major road at 45 and 53 years of age and probable sleep apnea at 53 years of age, after adjusting for the minimum set of confounders. And there seems to be quite a paradoxical relationship between increase in the annual mean of air pollution exposure and a reduction in the odds of probable sleep apnea, which is really strange to me. And for the sensitivity analysis, restricting to those who remain at the same residential address at both time points. Similarly, there was no association between trap exposure and probable sleep apnea. And we can see the same strange relationship as the main analyses. And when restricting the analysis to those that had a sleep test, the associations are quite different to that observed in the main analysis, the main analyses, but nevertheless, neither an increase in the annual mean exposure to nitric oxide or PM2.5, nor living within 200 meters from major road at 53 years was associated with confirmed obstructive sleep apnea at 53 years of age. In the effect modification analysis, there was weak evidence against the null hypothesis that current asthma and being a smoker modify the association between air pollution exposure and probable sleep apnea. And this was seen for both the cross-sectional and the longitudinal analyses. And I'm happy to flip back to these result table later on for further questions. And this table shows the characteristics of those lost to follow-up. And there are noticeable differences in the characteristics relating to smoking status and participants from a low socioeconomic status, all of which can potentially bias our findings. So in summary, for the main analysis, there was no evidence of association for trap exposure at 2 time points and probable sleep apnea at 53 years of age. And when restricting to those that stayed at the same residential address in both decades and those who underwent a sleep test, there was no association for trap exposure and sleep apnea as well. And we saw no evidence of effect modification by asthma status or smoking status. Some strengths to the study. So this study adds to the literature gap in the association between trap exposure and sleep apnea in a low polluted setting. And this is a population-based sample, not pre-selected for sleep apnea, and thus minimizing the risk for selection bias. We were able to examine the long-term effect of air pollution using longitudinal analysis, as opposed to most studies, which only looked at the cross-sectional association between air pollution and sleep apnea. We also used the optimal cutoff point for the screening questionnaire, thus maximizing the sensitivity and the specificity in detecting people who are likely to have sleep apnea. And we've also used a robust then-use regression modeling technique to ascertain the concentrations of air pollution. Some limitations and room for improvement in future studies. This sample population has the same age, so future studies may wish to examine the effect in other age groups as well. And future studies may want to increase the sample size of home sleep tests to more objectively look at sleep apnea. And the results are only applicable to middle-aged people who live in a low polluted setting. Now, because of the seemingly paradoxical relationship between air pollution exposure and sleep apnea as observed in my analyses, here are my plans to extend the analyses, and I welcome your suggestions and further input. So I plan to explore the outcome as no sleep apnea, mild and different severities of sleep apnea using a multinomial logistic regression. So in the current analysis, I have only included those with mild to severe sleep apnea, and this restricted my sample size from 264 to about 141 participants. And I plan to explore the outcome as a continuous variable. So basically, instead of categorizing the apnea hypopnea index into different severities, I plan to look at the association between trap exposure and the change in the recorded apnea hypopnea index as a continuous variable. And the authors of the stop-bang instrument have shown that the score in a linear scale can be used to indicate the severity of sleep apnea as well. So instead of using the optimal cutoff score of 5 out of 8, I will use the stop-bang on a continuous scale. And I also plan to explore trap exposure as the difference between the upper quartile and the bottom tertile, as opposed to looking at the middle 50% or the interquartile range. So what is the take-home message from this presentation? So there is a growing interest in looking at the association between air pollution exposure and sleep apnea, but the current literature lacks well-designed studies looking at sleep apnea in children from low-income countries. And as mentioned earlier, there is a significant disparity in the exposure to air pollution between middle to high versus low-income countries, and this can differentially affect the risk for sleep apnea. The current studies in the literature cannot disentangle the difference between indoor and outdoor air pollution, and although land use regression modeling and fixed air monitoring stations are commonly used techniques to ascertain the amount of air pollution exposure, these techniques do not adequately capture the sleep environment, and it may be more informative if we can compare the indoor versus the outdoor environments in future studies. The upper airway irritant and seasonal allergic reaction are not mutually exclusive, and seasonal variation should be taken into consideration when performing analyses. And this is an important point of consideration for upper airway conditions because nasal allergies can increase nerve excitability in airway and can intensify responses to nasal irritants. And conditions such as allergic rhinosinusitis also exhibit a seasonal trend. And although there was no evidence of association between trap exposure and sleep apnea in Australia, this does not indicate that there is a safe threshold. And perhaps a lower level of air pollution may need a larger sample size to be able to detect an association. So thank you very much for your attention, and I welcome any suggestions, any questions on my presentation.
Thank you very much for that, David. That was really, really interesting. A really, really good overview of a health impact that many of us, myself included, were not really aware of and certainly not across. So are there any questions for David or any comments in general? I know David was very open to comments on his work so far and future directions for it. Yes, Christine?
Hi, David. Thanks for the talk. It was really interesting. I know you showed the slide with the mean pollution levels, but I didn't get it. Can you describe what the range was like? And maybe it's a factor of there being a small range in pollution. That might also be an issue for your work.
Yeah, so that's,
thank you for that. There's not much variation in pollution, you're not going to show an effect even with a large sample size, maybe.
Yep, so that's an idea that I did think about, because I do notice that the difference in the air pollution level at the 25th and the 75th percentile very minimal. So there isn't much of a spread in terms of the air pollution. So I was thinking whether I should look at the upper quartile, and maybe there may be an association there as opposed, and compare that to the lower tertile. So that's just a plan that I'm planning to look.
Yeah, we've done that in respect to a different to respiratory outcomes, and unfortunately didn't show any difference. But certainly, it would be interesting to see if your results do show an effect.
Yeah, and it's also quite interesting because in another study conducted by within our unit, we did see an association between the same levels of air pollution and asthma.
Oh.
But it's not the case with sleep apnea.
So they were okay. So they weren't any higher, those air pollution levels. Is that Guyan's?
Guyan's, yeah. So that this comes from Guyan's work.
Yeah. Yeah.
Nat, I see you've got a question there.
Yeah, thanks, David. That was a really good talk. It was really clear. Yeah, Christine's the expert on the air pollution side of things, and I'm the expert on the sleep apnea side of things. And you've got there's a bunch of really tricky variables in there that they're quite hard to manage sometimes statistically, and also the physiology of them is a bit questionable, and that might explain a null result too. But I guess one of the things I've noticed was that the number of people that you had actual sleep studies on was only quite small. It was only like 260 of them, and it seems like, unless I misread the slide as it was coming past, that absolutely every one of them tested positive for sleep apnea. Is that true, or did I just completely misread that?
264 participants underwent the sleep tests, and more than half of these participants had some form of sleep apnea, which is quite different to what was actually picked up using the sleep apnea instrument. Yep.
So 264 of them, and then
Yep. So the sleep
so
apnea
74% and 26% implied to me that all of them tested positive. Okay, I did misread it.
Yep. So more than
so
half.
The problem, AHI is a really tricky variable to analyze sometimes, because in a population sample, the most common AHI should be 0 and then 1 and then 2. So it's almost not, it's not a continuous variable so much as it's almost like a count variable. So you sometimes start wondering whether you should be doing Poisson regression on it, funnily enough. And the other issue is that epidemiologically, the stop bang score is a bit problematic too, because it's basically made up of asking people, are you a guy? Are you really overweight? What's your age? And so now we've got on the left-hand side and right-hand side of our equations a whole bunch of confounders in there. And stop bang is not really a good epidemiological tool, because it was actually developed by anesthesiologists as a checklist for surgical safety. So it's a quick way of working out, is my patient got sleep apnea, and are they potentially going to have a bad anesthesiology kind of outcome because of that? So keep a kind of closer eye on them. And so it's kind of leaked out because it's cheap and easy. And again, it is also, it's problematic logically, and it's also just not that sensitive or specific for sleep apnea. So it's, it's a tough problem. My suggestion, having looked at this with Christine a few years back, where we did this for the European Respiratory Journal on temperature and sleep apnea.
Yep.
And we wrote an article basically saying we're completely Scoobied because we couldn't work out whether temperature going up or down made sleep apnea worse or better. So I share your, I guess, frustration with the lack of an obvious pattern here. So it's really impressive talk that you gave dealing with that. I guess in Australia, we've just had a really fantastic and horrible natural experiment where we could look at this with the bushfire events at the end of 2019. We could look at whether the sleep apnea severity went up because of all this horrible crap we were breathing in. So that would be a cool thing to do.
Yep, that's quite an interesting point that you brought up, Nathan. And we are planning to start another follow-up study within the TAS next year. So and we are going to continue to measure sleep apnea using the Stop Bang and the Berlin instruments. So there is a chance there to look at the analysis at 2 different time points to see whether find a more interesting finding.
Yeah, just got to be careful with Stop Bang because, like I said, it's built up out of I guess, an old-fashioned 1980s way of thinking about what sleep apnea, who gets sleep apnea, and so it doesn't change. Your genders, they're not going to change. Their ages are going to change in a predictable way, and so a lot of that information can't and won't change.
Yeah, but I do agree on that point. And this goes for the OSA 50 and the Berlin questionnaires as well, as they also have poor sensitivity and specificity.
Thank you very much for that. Do we have any other questions or comments? If you do think of something later, because I don't remember if I've included your email in the flyer, David, but do feel free to also reach out to David if there are bits of advice, because this is, I think, an incredibly important area of research and a very obvious gap as well. Now that you've started to dig a bit below the surface. So yeah, if there's no other questions, we'll wrap up there. Want to thank you very much, David, for your talk today. Incredibly interesting, and yeah, I look forward to hearing more about your work as it progresses in the future.
Thanks, Nathan, and then thank you for everyone for your time today.
Excellent.